Welcome everyone to another nightly update here with our fun RISC-V FPGA ULX3S fun. And as per previous video on the main channel here, our work on enabling SD stuff, and I figured all the remaining details out. Sometimes you just need to stay another hour or two longer up and stuff through the night. And anyway, you get the idea. To provide you a summary of the last remaining bits and features, what we have here now is fully reading. You see here fully initializing. So figure this ASCII, this application specific command stuff out and all the reading bits, and walk you through the remaining bits and pieces. And again, for all the previous details, main channel there, all the enablement and pain of debugging this and on-chip logic analyzing and all the other fun and massive frame drop, because now let's load here my second browser and get started. So the thing is, not sure where I ended in the previous video, a little bit frustrated as usual per the implemented so many details and still not working. And the one thing is those commands here that previously probably we stopped at this ASCII, this here, is this not working? And it turned out these are not hex, these are decimal. That explains the thing so much, to reading all the details in the specification. And 900 so much to, I really wonder how this can be, this bloody cable can be so overloaded, because don't think too many people are up at this time here anyway, or everyone is watching Netflix. So first mysterious thing is, I think we got like, what did we get? Invalid command, I think, maybe, if that was still on the other live stream. So now we are getting for all the commands here init, and this here is then one of them 48, 77, 69, 71. Let's see which was which. These are the commands, and for the details, previous video, otherwise it gets too long here. And so 8 is, so these are also with this start bit that our code sets automatically. So command 8 for in idle voltage ranges, and then we initialize this here, and that is previously did not work. This ACMD, I also wrote a function to this, because factoring out there most of the code and having this most streamlined. And so ACMD, this is doing the command as per previous video, and now it's decimal because it's decimal. Also here, right, this here, probably not sure if it's somewhere written, but whatever. And then this works. Previously the response was, I think, illegal command or something. And then send this command. So first, it means the command structure as per the specification previous video is the same. So starting to get a little bit of code reuse. And also that's not indented properly. And next, so we are fully initted. We also need to repeat this. So previous video, see, this is repeated twice. So I think I saw this here somewhere in probably the flow. So here's some error of repeats this because it doesn't initialize quickly. So then was reading, obviously sometimes you need to just stay a little bit, otherwise if I continue tomorrow I need to get into the mood and more efficient to just finish it. So reading is ideally, all the cards also have another block size. So for really production code we need to set the block size for something probably 512, because the new ones come up at 2048 or so. Anyway, I wanted to read some data out of there before going home. So that is a command 17, which not hex but decimal, as we learned. The command response, I think, are one of these command responses, and then the data packet. And that also did not just work. Let's see, this is some garbage. That probably was this. And I quickly noticed on the first glance, like, this probably is not really right. And if we take a look here, at least on this side, and certainly somewhere in the specification, that we also this partial specification of really not cool. And as you see here, okay, these are just CRC7 examples. This probably is listed here somewhere as returning some special token update, something. Where would it be? Anyway, certainly you find it here somewhere. Here's response data block and data read, exactly this one. And so it has here some special data token. It's probably somewhere mentioned in all this gibberish. And welcome there. So it looks so simple, but yeah, we get here some FFFs, and that immediately look like, yes, it's probably not our partition table, because we are reading for test 0, block 0. And yeah, let's see. Christian writes, sorry for going, what, mirror? What do you mean? I don't really remember anything negatively whatsoever. What you're talking about, everything is good except except bloody it's hilarious. Bloody DOCSIS cable, not recommended. Probably call Vodafone cable stuff. So yeah, implementing SPI SD stuff from scratch as per the previous video. Shared here the duty between Verilog, so the physical wire interface with FPGA to drive the signals here of, is it even the right card and the right camera. So also what I wanted to mention, that you learn something more than less, is the play of hardware and software. As in, of course, you can implement the whole command structure in Verilog, but certainly that is more error prone, and in probably it's more flexible. You see, we have here the physical interface as stupid, keep it stupid as possible, and this to the RISC-V CPU here with the system bus, and still our keep it stupid simple logic analyzer attached to that, and here's the system bus for the RISC-V. So the RISC-V CPU is actually also on our FPGA, right? That we synthesized ourselves. The like driver, like operating system, soon driver that we can recycle in our operating system for all the SPI goodness, microkernel that we write next. So in my opinion, probably much more flexible to have this control structures here of commands there in operating system, firmware, driver, because you see the added compile cycle with Verilog, it would like days of getting gray hairs and head scratching. And yeah, so we are driving here our own with the RISC-V, so we're compiling the C code to RISC-V. The RISC-V machine code is running here on the FPGA, and yeah, these are the commands. So the read block, here is some command response that is an error, that we should certainly not have an error. And if you take a closer look here somewhere, there is some data token, and this data token here is, so as per usual, nothing in this SD card stuff is that straightforward. Always a little bit linear, some committee and between the toilet and some meeting invented here. And so instead of, yeah, I somehow do not really quite get why the error code is not in the, it could, for example, have here like this main response, primary, where is that even? It could have in this command response already like idle while busy, but it doesn't. So it has some additional data token in front, also after the command response, in front of the data, the stupid data token, which are here all the FFs. So I also, next after I saw this, so this is like all bits set except then command something 0 for we're finally ready. I also don't quite get why, yeah, whatever. If you were certainly invented in the 90s and the garbage protocols. And for those who are not in software and hardware, this is why everything is error prone and complex, because here's some bits, there's some data token, and here's the specification is only partially published because of SD association secrets. So yeah, simplified of all the good stuff missing, whatever. Anyway, so we basically only need to wait for the data token. Of course, we have some timeout. If you don't have some timeout condition like milliseconds or loops like 64, then you could potentially deadlock forever, like waiting forever, never finishing, like with 3000 drop frames of not amazing Vodafone cable docks is garbage. I hope the audio doesn't have dropouts. And yeah, so that's what we're doing here just for now. Is the read here. So we issue the command 17 for reading. Also, yeah, the address here, hopefully big endian, shifted here in 8-byte stuff. Theoretically, everything could be done a little bit more efficient, but yeah, for a start, we do this. Then the generic previous video main channel. Command 17 here, the size of command 17, and nothing to read because initially I had here read the whole block, but that doesn't work because we need to skip over this token. So we unfortunately cannot use our generic data block read because yeah, skip over data token stuff. So this token uninitialized intentionally, waiting here because this will guaranteed run. So no point to initialize this here, in my opinion. A good compiler should be good enough to catch this, that this loop is running because we assign it here. And wait for this token. Right now this token should be this command 70 token, so it should probably be only this one. So right now we only check for this one. FF is busy, so check this also, otherwise log it as unknown token. Didn't happen yet for me. And so reset this token because we reuse this variable for success. So this is why I zero it here after the loop, because it could be end of loop. So not to cause a bug there. So if we got a token, like we didn't zero it out and we broke out of the for loop here with a valid token, then we can finally read the data block that we wanted. And that is just reading it in. Probably I make here also reuse SD read loop here maybe, but whatever. For also, yeah, for now super inefficient because logging it. And then when we are done, also read the CRC here, just in case there's a CRC that we should read, check some, but also later we probably should check. And that's it, we got the data and we are logging it here. And this is a printout here. So this is the data FAB something. And when we compare this to Wikipedia, I have here the Raspberry Pi SD card from the previous video, Raspberry Pi 0 in for a test, and where we soon want our JPEG and audio data for audio, feel and game, Pac-Man and Tetris logic, there, fun stuff with our direct stream digital audio stuff and so on. So if we take a look on Wikipedia to get a look here of how this good old-fashioned PC master boot record stuff looks, here sector layout, some partition entry, and the structure of a modern standard. So bootstrap code 208, so this is machine code. There could be something potentially, maybe printing out not bootable of some stuff, many zeros, and certainly some partition table somewhere. And here at the end 55AA, and for all of those who ever played on low level stuff on the PC, you might find here also documented that the boot signature is 55AA. So much to getting our first sector here, and a lot of drop frames out of this SD card here live on YouTube. That's it for this achievement. So finally huge progress, audio, video running right now. So next upping up the frame buffer with more bitdef stuff, and then decoding, loading from the SD some files. Also, yeah, next file system. So blocks are raw blocks, and next, so we need to implement for our microkernel also. So goal here of, I said this before, Rosetta code of most readable code. Not yet the supermost, so we also need to work to establish here some framework of really readable best practice. Right now it's like relatively good for somewhat live coded on YouTube, but certainly we need to make this much more amazing. But we got the first sector out of there, and can also show you that if we take this out, I've actually not tried this, but it probably should give some, doesn't work anymore. So yeah, no SD card, so much to that fun stuff here. And yeah, pretty nice progress, a lot of stuff learned this week. I hope you learned something too and enjoyed this fun little ride here on this channel, all bits and electrons low level. First stream in a while, able to present in chat yet. I think you didn't really, I thought you were quite often, but yeah, anyway, thanks for watching. And yeah, Christian recommends fine Chinese awesome people who are the best people to find documentation that's not meant to be seen by the regular people. Yeah, exactly. That's probably a good thing here to end the stream, which totally 3000 drop frames because garbage, DOCSIS cable stuff. Anyway, I'm super happy with my code here. Also, this will not work. Oh, it does work. Actually, that is funny because I thought it doesn't init. And interesting because that means that I would have expected this not to init because it needs, they write it needs 74 clock cycles, and because we did not reset this, it did not init. It didn't do my Verilog code is doing this 80, like 74 plus 80 clock cycles of init. So this is interesting that it did init without that. I didn't expect this. Anyway, yeah. So next partition code. So all this stuff, and then we need to establish some really good. The problem is I want to have this code like shareable, and that makes C++ a good candidate. However, as I mentioned before, not the greatest fan of error-prone stuff. In my opinion, it would be so cool to have some C++ Lua-like hybrid of really totally amazing code that would make readable code and would make coding so much easier, but that would not be super portable code. So we need to think, but for now we continue with C. Try to make this a little bit C++-ish, a little like not like super fancy, but maybe using some G++ features to keep the readability a little bit higher, above average, hopefully. And yeah, so this will be shared, this pieces. So when we write now partition master boot record, fdisk like partition table reading code, and then file system. So we need to implement fat, for example, for this, but then also maybe something else. And not only for this, as I said, always best practice examples and readable code for low-level firmware stuff, microprocessor controllers, like amazing state-of-the-art RISC-V stuff, and also wrong camera, too many cameras. So yeah, hope you learned something. Super happy that this finally works, and then we can make the next amazing progress. As usual, leave in the comments what you think of all the hidden partial simplified specifications, what you learned, not learned, and yeah, made some vote. Hey, welcome everyone. Of course, as usual, although, yeah, finally I want to get home after spending an extra hour getting this stuff to work, but then the people tune in, highly appreciate it. Hope you learned something. Probably you want to rewind and watch this. Let's see, we could check here also the other stream that failed a little bit, because really annoying that a new subscriber, Robin Hood, amazing stuff. Welcome to this channel. And also someone unsubscribed, I think we had already 69, I think. And what's going up here? Oh, this is my own live stream. As per the community post here earlier today, I guess people are really waiting for P3, so probably we need to satisfy those. And the new, whatever you prefer, yeah, P3. Obviously, thanks for that. Also microkernel and FPGA. Anyway, yeah, so at least we're getting with microkernel FPGA. Crackling audio, really? Did I not reset pulse audio? Oh, come on. Wonder. Anyway, that's it for today. Anyway, I need to check also, darn, don't tell me all of the both videos were crackling audio, because I'm running I'm running the old Linux kernel for this stupid secondary Epiphone capture thing. That's why I have two camera views, need to run the... Also another thing that we eventually need to reverse engineer. Anyway, that's it for today, and I hope to see you soon for the next videos and live streams to come.